a geological challenge. Numerous exchanges take place between France and Italy every day. Currently, cars, trucks and trains went slowly through the valley. Not only is it slow, but these routes regularly suffer from climate hazards. These landslides are said to happen more and more frequently with global warming. We are seeing a cycle of multiplying droughts followed by heavy rains. A soil that dries out and then swells with water moves a lot, hence the landslides. To stop relying on the weather conditions and to create a direct path, we started building the longest mountain tunnel in the world, the Lyon-Turin Megaproject. This tunnel is about as long as the Channel Tunnel between France and England, but it is much deeper. The English Channel is shallow and the tunnel is just below the seabed. In the channel, the pressure is only about 10 bars and the temperature stays around 20 degrees Celsius. However, under the Alps, the tunnel reaches depth of over 2,000 meters. The pressure exceeds 600 bars and the temperature hits 50 degrees Celsius. The difficulty mostly comes from the geology inside the Alps. The Alps were born from the collision of Africa and Europe as they moved closer together. Before, there was a flat plain with forests and an ocean. As the place closed in, the earth folded, creating the Alpine mountain range. We see similar cases elsewhere, like the Zagros mountain formed by the convergence of Iran and Iraq. Long ago, there was an ocean filled with plankton. Plankton falls to the seafloor. Then, the plates move closer, forming the mountains of Iran. The plankton cooks slowly over millions of years, turning into oil. Thanks to the folds, the oil gathers under impermeable layers of evaporated sea salt. This explains why there is so much oil around the Strait of Hormuz. In the same way, we find oil around Turin in Italy. Because the Alps are so massive and heavy right next to it, they pushed the plain down. The oil is very deep, discovered by Inai at 2,000 meters depth. But inside the Alps, the shock was so violent that the oil overcooked. Too many folds allowed the gas to escape. All that remains is coal and graphite, forming highly viscous rock layers mixed with a hard continental basement known as an ice. Drilling into an ice is like making a hole in wood. It creates a perfect round straight tunnel. But this burnt carbon in layers is soft. It's like digging into a wet phone book. To prevent the tunnel from collapsing as soon as it is dug, there is a trick. Here is a simulation of our arts. If we dig into the ice, it holds. Now let's look at the coal and graphite layers. If we dig and immediately try to hold it with rigid concrete, the extreme pressure would crush the concrete instantly, causing the tunnel to collapse. So what we do is dig a larger hole and let the mountain relax. We use flexible concrete that hardens slowly, combined with sliding steel rings that allow the diameter to shrink until the pressure stabilizes. This is how we master the weight of the Alps.